So for question B, we've already got our stationary points. We've already given the key functions, key features of our function, stationary points, but now we need to find our intercepts and our key features. So let's find our x-intercepts first. And that occurs when y equals 0, or fx in this scenario, and fx equals 0. So we want 0 to equal our original function, which is x squared minus 4, x squared minus 16. Now that only occurs, like with many of these problems, that only occurs when either this thing equals 0 or this thing equals 0. So that occurs when 0 equals x squared minus 4 or 0 equals x squared minus 16. In both of those scenarios, I rearrange to get x squared by itself. Okay, I square root both sides. 4 equals x, square root of 4 equals square root of 16 equals x. Obviously that will need to be a plus or a minus. So I get plus or minus 2 or plus or minus 4. So this function has 4 x-intercepts. Negative 4, negative 2, positive 2, positive 4. There where the x-intercepts occur. We don't need to do our y-intercept because we already have that from the previous question. Okay, but if I need to find my y-intercept, what I would do, y-int, I would let x equal 0. So I get f of 0 equals 0 squared minus 4 in brackets, 0 squared minus 16 in brackets, and that gives me positive 64. Okay, negative 4 times negative 16. When I come to graph that, what I like to do is I like to just put dots on my graphing space. Okay, I'm going to do a big, nice and big graph up here. I'm going to need it to be extremely disproportional. I like to put some dots on, so I know that I've got a dot in it. Let's just call this negative 4. Let's call this negative 2. Let's call this 2. Let's call this 4. I've got dots at all those points. The function is going to run through every one of those points. I also know that negative at root 10, which is I think 3.3. I'll just shove it in my calculator to get an approximate value. Okay. I know that it's a little bit more than 3, but it's less than 4. It's probably 3.16. Okay, so my square root, my stationary point is going to occur somewhere here and somewhere there. I don't know exactly where yet. I'm going to find that out. Well, I do know where, but I've got to put it as a dot. I'm just going to make a mark here of, well, not that far down because I need it to be proportional. I'm going to call this point negative 36. I need a point there. It's call that 64. Obviously, you'd be far more precise than I am. So I have a turning point at this point here and a turning point at this point here. And now all I need to do is trace my way through to connect the dots. And we get a big W looking shape. Okay. If I didn't know a piece of information, like if I hadn't found my intercepts and I wanted to find out whether that was a minimum or a maximum, okay, and we'll talk about global minimums and maximums in a second with this graph, but if I wanted to know about whether this was a minimum or a maximum, a local min or a local max, what I would need to do is obviously do that little table below where I'd have the gradient here, the gradient there, the gradient here, the gradient there, the gradient here, the gradient there, and the gradient there. Okay. So in that graph, because I've got 3 turning points, I'd need to have 1, 2, 3, 4, 5, 6, 7 rows in my table. Okay. Obviously, we'd expect to see negative gradient 0, positive gradient 0, negative gradient 0, positive gradient, which should tell you what that function is doing. Okay. These 2 points here represent the minimum. Depending on where our domain lies, this may represent the maximum. It might only represent the global maximum. We'll talk about that later, the local maximum. We'll talk about that in a second.